So let's start with the leg. I'm going to talk through what I've built for this character step by step, and then hopefully in the end everything will make sense. But for the leg and for the arms, I'm using the same function, which I called limb IKFK. So basically inside this function, we will do an FK setup, an IK setup, and they both snap when you move the controllers. So for example, in this left leg here, I have an IK setup that I can just move around. I have a pole vector here. And then if I come to this control, which I can access from here, the switch, and I switch to FK, it snaps to the correct position. Then same thing, if I move the FK and I switch back to IK, switch, it switches back and then calculates the right place for the pole vector, which in this case is a bit far away. So let's see how I've done this. So first thing, I'm passing the joints. In this case, there are 3 joints, so hip, knee, and ankle. Then I'm passing the IK control, which is the main IK control in here, IK. Then I'm passing the IK control ball, if it's for foot. If it's for the arms, I'm actually passing the same thing, which is this one, ball. And I'll show how I've done this setup of like row as well. Then I have the pole vector control, which is here. Then I have the FK controls, which are 3 as well. Then I have an option to stretch, an option to switch IKFK, and an option to follow the pole vector or not. So if I go to the FK mode and I move around, pole vector is not following. But if I go to left leg pole vector auto, if I press this, hopefully, yeah, it should just follow the IK control. And I also need to pass some axes, so the primary axis and the secondary axis. So to be clear, let's just double click here. Sorry. So I'm inside the limb IKFK function now. So what I did is that as I showed in the previous video, I created all these elements to pass. So just talk over it. So joints are the rig element key as an array. Then the controls are just a single. Then FK controls array again. Then stretch, it's boolean. I've also put this option to change how far I want to stretch or not. So I put them as a float. Then I've added a debug. I think I didn't create a controller for that, but then I have a boolean for IK FK switch, a boolean for follow pole vector, and the axes, as I said, they are vectors. So what I've done here is that, as I said previously, I create a sequence, and the last thing is the return. So the first thing is that I create a branch, and I get the condition if it's an IK or FK switch. So I connected this here, and then if it's an IK, I'll go up here, true. And I'm just using the IK2bone, which is a function that comes already with Unreal 5. And I'm connecting let me just move this here. I'm connecting the primary axis and then the secondary axis. Then I'm using this, the IK pole vector control. So this is, instead of connecting directly from here, IK, dragging here and putting here, what I'm doing is that I can right click and say get IK control, and then it'll give me the options that I have in my function. So I can just get the main or the joints, basically anything. And that makes it easier to read the graph as well. So I'm passing the pole vector control. Then I'm passing the 3 bones from my chain. So what I'm doing here again, because they are an array, so remember the joints here. There are 3 joints. So I'm using this function here called add, and I'm passing the index of each of them. So index are these numbers here. So index 0 is the hip, index 1 is knee, index 2 is the ankle. So if I grab these and I write add, I can pass in a specific item inside this chain. So I'm passing 0, 1, and 2 as bone A, B, and C. And then the end control, which is the control that will actually move things around, is my ball control. And that's because of the way we need to set up the foot row. So this way, actually the ball control is the one moving it. But because the ball control is under the leg IK, if I move the leg IK, everything moves together. Hopefully that makes sense. And then I've attached also the stretch settings and the enable stretch boolean that were here, and the debug that I had in here as well. And that's the IK. So what I'm doing here is I'm doing the follow pole vector. So I'm using a position constraint, and I'm getting the pole vector as a child. Then I'm getting the IK control main, this one, as the parent. And to save if this is going to be valid or not, I'm connecting to the weight. So I'll just open this position constraint again so we see how it is as default. So this is how it looks like. If you need to add more parents, you can just add it here, and then you can set the weight for each of the parents. In this case, we only have one parent and one child, and I'm connecting straight to it. And then I'm using the weight to see, to tell if it's valid or not. So I'm getting the follow pole vector boolean, which is yeah, pole vector auto is this controller here. So I'm actually typing get pole get follow pole vector, and then I'm attaching to here. So basically, if it's 1, if it's true is 1, if it's false is 0. And this way, if I connect to the weight, if this here is 1, it will be true, so the position constraint will work. And if it's off, like is here, will be 0, so then the weight will be 0 and the position won't be moving. And then the last thing I do is that I do the FK's controls to follow the IK. So what I do is that when we move the IK control, of course we are moving the joints. So what I want to do is that I want to pass the joint position into the FK controls, kind of a reversed FK chain, let's say. So I get the main joints, which are these joints here. I get the transform. So if I just drag here and type get transforms array, I get the transform of them. and then I get my FK controls and I set transform. So then I connected the transforms from the joints to the FK controls in here. So then if this switch IK-FK is false, we'll go down here, and that will be just an FK chain. Also, this is an Unreal function. You will notice that if you switch let me see if it works in here. Basically, it gets is because this function is using more than once. But basically, you would see in bold if the value is true or if the value is false. But because it's being used in the other limbs, I think it doesn't work like that. Anyway, yeah, so if it's false, then I want the FK setup, which is represented by my right leg here. So I get the main joints and the FK controls, and I just connect them to the FK chain. Then I want the IK control to follow the FK. So this works a bit differently because it's easier to tell the joint position and then place the FK controls where they should be. But how should I place an IK control in this situation? So the main thing that drives the IK control is the IK setup is the IK control. And I know the IK control needs to be in this position of the ankle, right? Because if I switch, here, I want this controller to be in the position of the ankle. So basically, this is the information I'm passing here. I'm getting the ankle control, or like the last control of the chain. And the last control of the chain, as we said, is the index 2. So if I go back here, index 2 is the left ankle or the right ankle. So I'm passing the index 2, I'm getting the transform of this bone, and then I'm setting the transform to the IK main control, which is this one. And this way is almost like if I'm parenting this bone, the controller being the child and the bone being the parent. And I can get the correct position for the IKs. And then I also need to compute the pole vector. Oh, this is why it was going too far. It's because I put here as a offset 200. I think it's a bit too much. But yeah, it's so I'm using the when we do the switch, although the IK control will be placed here, I need to also calculate where the pole vector will be. And then for that, I'm using also the function that comes with Unreal called compute pole vector. So I'm getting the main joints. I'm doing the indexes again, so 0, 1, and 2 for bone A, B, and C. And I'm getting this transform, and I'm setting the transform for the IK pole vector. So if I do this way, then it will calculate according to the position of the bones, it will calculate where the pole vector should be. And then I'm positioning my controller where it should be. So this is the IK and FK. We're going to use the same setup for the arms, and basically you could use for anything that is a typical IK-FK chain. So what I'm doing here is doing the controls visibility. So basically I have this controller switch IK-FK, and I want to say when this controller is on, just the IK controllers are visible. When this controller is on, the FK controllers are invisible. So this is what I'm doing here. So from the sequence, I come down to here. I'm using set control visibility, and then I'm getting the IK control, and I'm getting the switch IKFK just connecting to be visible. Same for the IK pole vector. And then for the FK controls, because I have more of them, I'm just using and for each. So if you drag these and type for each, you get these nodes. And then for each, I'm then setting the control visibility. But in this case, instead of connecting directly from the IK-FK switch, I'm first passing a NOT. So again, if I just come here and paste NOT, so NOT will give me the opposite of what is here. So that means that when this is on, these are visible on, and these are not visible off. And that's how I set up my controls visibility. So this is my whole function. I can use it in other parts of the body, as I mentioned. Basically, this is how it will look like in the normal, in the main rig graph. So here I have the forward solve. So forward solve is basically the main rig, how we are going to connect controllers to joints. And then I'm passing it to the legs area. As I mentioned here, I have the left side and I have the right side. And basically it should already work if I just literally Control C, Control V here. I get another function, and I could use for another any set that I want of IK and FK setups. So I'm going to show how I've done the foot now. So for the foot, we have in the IK mode, we have a row setup. So the IK is normal, but I can row heel row, and I have the toe row, and I also have the ball row. So this is cool and super important when you're doing like simple walk cycles and things like that. For the IK setup, for the FK setup, sorry, I just have one control here for the toes, and that's it. So what I have in this function, I called it a forward foot. So what I'm passing here, I'm passing the ball joint, which is this one. Then the ankle joint. Then the ball FK control, which is the one that I showed. Then the toe row control, ball row control, and heel row control. These controls are basically just placed on here, and they're all parented to the leg IK. And then I also have an IK-FK switch here. I'm connecting with the same control that I have here. But yeah, let's open and see how it looks like. So in this one, I actually, instead of get the joints, I just connected the main things in here. So that's why it looks a bit messy. So first things first, sequencer, and then last thing being the return. The first thing I do a branch that gets me the condition of the IK and FK switch. So if it's true, I am creating a parent constraint. So the child is the foot joint, and then the parent is the row control. Uh, I'll say this in advance. This row foot doesn't make much sense. I really recommend you just follow the steps and execute. It's quite hard to understand why the order of these things. I personally always feels a bit confused, and I always need to go back to tutorials to double check what I'm actually doing. So yeah, so the parent is the ball row control, and then the child is the foot joint, which is the ankle joint. And then I have another one for the ball joint and the toe row control. So the toe row is the parent and the ball is the child. And then this if it's true, and then if it's false, it's just the FK setup, which is a basic parent constraint from the ball joint to the FK control. And then again, I have a visibility setup here, which works in the same way as the IK. I get the boolean of the IK-FK switch, and then I get the IK controls, and so these three are the IK controls because they are connected directly to the IK-FK switch, and this one is the FK control. So I'm getting a NOT and then FK control visibility, and that's how the legs are set.